indicators. So there are solutions out there that will change when a solution will change its color. So a solution that changes color due to a change in the pH value. So these are a nice visual indicator for us to show us when the pH value of a solution is shifting. It's either becoming more acidic, so the hydrogen ion concentration increases, or it's becoming less acidic, more alkaline or basic, because the hydrogen ion concentration decreases. Now, there are many acid-base indicators that exist in nature and that are used in labs. We have to work with a select few that are on our table M. Now, the actual color change occurs within a limited pH range, and the indicator only shifts between the two colors. So a common acid-base indicator is bromethymol blue. So a lot of times you will see it abbreviated as BTB. So bromethymol blue, it shifts between its two color choices somewhere between a pH of 6.0 and 7.6. So the two colors. If a drop of bromethymol blue is put into a solution that's pH is less than 6, bromethymol blue is going to turn yellow. If you put a drop of bromethymol blue in a solution whose pH is greater than 7.6, the bromethymol blue will remain a blue color. So bromethymol blue switches between a yellow and blue color. pH less than 6, it definitely is yellow. Greater than 7.6, it is blue. So there's a small range in which it shifts between the two colors. Another example is methyl orange. So in our labs, we'll see it labeled as MO. Methyl orange, when you look at it based on its name, it's a bright orange color. When it is put into a solution, okay, it will actually exhibit two different colors. At the lower pH value, it will actually turn a bright red, and at a higher pH, it will exhibit a yellow color. So methyl orange will definitely exhibit its red color if the solution that you put it in has a pH of less than 3.1. So if the pH is really acidic, less than 3.1, methyl orange is red. If you put it into a solution where the pH is greater than 4.4, it definitely exhibits its yellow color. And our last example, phenolphthalein, probably the most common indicator out there. Phenolphthalein, it exhibits two colors. So at the lower pH range, it is colorless. So it looks like just a glass of water. And at the higher end of the pH range, it's this really bright pink color. So phenolphthalein will remain colorless and looking like plain old water when the pH is less than 8. It will start to exhibit its pink color when the pH is greater than 9. So the shift occurs between 8 and 9, but once when you hit a solution of like 9.1, it definitely exhibits its pink color. So we keep it simple. We're not going to overanalyze these. So if the pH is less than the first number listed, the first color is exhibited. If the pH of the solution is higher than the second or the ending number in the range, then it exhibits the second color. So we're going to keep it simple. So take a look here. An example question from some previous exams. So a solution was tested both with bromethymol blue, so that's our BTB, and methyl orange. So when the bromethymol blue turned yellow when it came into contact with this solution. So bromethymol blue, it exhibits its yellow color, so the pH has to be less than 6. So the solution's pH has to be less than 6.0 because bromethymol blue turned yellow. So if we look at bromethymol blue, we know that the solution's pH value is somewhere between 0 and 6. The methyl orange also, right, turned yellow when it was put into contact with this solution. So methyl orange, it's yellow if the solution's pH is higher than 4.4. So based on methyl orange, the solution has a pH that is greater than 4.4. So when we look at these two values, we understand that the solution's pH, okay? So the solution's pH is between 4.4 to 6.0. It's somewhere between here. So the solution's pH, it's greater than the 4.4, but less than this. So it's higher than 4.4, but less than. So the pH range, based on these indicators, has to be higher than 4.4. So we would say 4.5, but less than 6.0. So we'll just say 5.9. So if our answer is asking for a pH range, we would give a range of 4.5 to 5.9. Versus if you have to supply a possible pH value. So if you have to supply a pH value, you cannot give a range. You have to supply an individual pH value. So there are multiple answers here. You could choose a pH of 4.5, a pH of 4.6, 4.7, 4.8, 4.9, 5.0, 5.1, 5.2, 5.3, 5.4, right? 5.5, 5.6, 5.7, 5.8, 5.9. So any one of these is a reasonable answer if you have to supply a pH value. If you need to supply a pH range, then the answer is 4.5 to 5.9. So make sure you read whether it says supply a range or a possible pH value.